In the previous video, you understood what is beat. Let's do the mathematical analysis to understand what is the frequency of the beat. Okay. Now, what we'll consider two waves. Okay, so we'll consider two waves and both of them, they have the same amplitude. Okay, and both the waves will have the same amplitude, but they have different frequencies, f1, f2. Okay, this is the first one. Now the next thing what you are going to have, the displacement we'll consider. So S1 is equal to R sine omega 1 into t, and S2 is equal to R sine omega 2 into t. See, omega we can write it as 2 pi f1 and omega 2 will be 2 pi f2. Make sense? Now you have S1 and S2, correct? Now after that, see, superposition. What does the superposition tell you? S is equal to S1 plus S2. So you have S is equal to S1 plus S2 or R into sine omega 1 t plus R sine omega 2 t. Take R common. R into sine omega 1 t plus sine omega 2 t. Again, sine c plus sine d. So sine c plus sine d is what? Sine c plus sine d. 2 cos c minus d by 2 into sine c plus d by 2. Isn't it? If you apply this formula, then you are going to have 2r into cos. See, I'll write omega 1 as 2 pi f1. If you want, you can write it as it is. Or in this case, it's going to become omega 1 minus omega 2 divided by 2. This into t, because omega 1 t, right? Into sine of omega 1 plus omega 2 divided by 2 into t. See, this is going to be the final one. Correct? Now, see, you have understood what is the net displacement according to whatever we have done, the mathematical part now. Now, in the next part, what you have, see, now that you have the value, the net amplitude. So, let's write it as capital letter A or something. So, the net amplitude A is equal to 2R into cos omega 1 minus omega 2 divided by 2 into t. This becomes the net amplitude. Alright. Now the argument is important to calculate the net frequency, isn't it? Let's try to calculate what is the frequency. For the frequency part, when you have to calculate the frequency of this particular beat, now the most important part is the argument. Correct? So before that, what we'll do, we'll consider what is the maximum amplitude. With the help of that, we'll be able to calculate it. Okay. Now, first thing is, if we are talking about the maximum amplitude, okay, maximum, cosine is maximum at 0, correct, 0 it's 1, or any multiple of that, correct. That means it's maximum, that means the value, it has to be cos k pi, maximum. Now, k value has to be even multiple. Suppose if you have to have minimum amplitude, then the cosine value has to be in minus 1, which is odd multiples of pi. Correct? Cos pi, 3 pi, 5 pi, like that. That means if you have to have maximum displacement, either on the positive or on the negative side, the value has to be just cos k pi. K becomes any natural or actually any whole number, 0, 1, 2, 3, 4, whatever. Isn't it? So, we are not looking at just maximum amplitude or the minimum amplitude. We are talking about the maximum displacement. In the sense, we'll combine both of them together and we'll say maximum displacement. For this one, you have the cos value as plus or minus 1. So, cosine of an angle will become plus or minus 1. That means what you have now is that cos of omega 1 minus omega 2 by 2 into t is equal to cos k pi. Cos k pi. This is what we have. Now in this case, omega 1, omega 2, 2 pi f1, 2 pi f2, we'll write in terms of the frequencies. So what you have now is that 2 pi into f1 minus f2 by 2 into t is equal to k pi. Pi and pi cancels, 2 and 2 cancels, isn't it? Now what do we have? So you are going to have t is equal to k divided by f1 minus f2. This is going to be the time, correct? Now since we have the formula for time, now the amplitude, when there is going to be the maximum displacement in the amplitude, for that we can write that t is equal to 0 or 1 by f1 minus f2, 2 by f1 minus f2, so on and so forth. Okay, and if you look at this, the difference between the values is always 1 by f1 minus f2. Are you clear? The difference between any two consecutive amplitudes in a beat is always going to be 1 by f1 minus f2. Now what we understood is for the maximum displacement, correct? Either positive side or on the negative side, but your maximum displacement. Suppose we are looking at the zero displacement, okay, minimum, in the sense there is no displacement at all. Then in such cases, the cos value has to be 0. Again, we'll do a little bit of math for that one. What we get is that cos of omega 1 minus omega 2 by 2 into t is equal to, see, it's going to be a multiple of pi by 2, right? Odd multiple of pi by 2. So cos of 2n plus 1 into pi by 2. Now equate both of them. Again, take omega as 2 pi f. You have 2 pi into f1 minus f2 by 2 into t is equal to 2n plus 1 into pi by 2. Okay. Now first turn, 2 and 2 cancels, pi and pi cancels. Okay, you can take 2n plus 1 or 2k plus 1, doesn't make any difference. So now time t is equal to 2n plus 1 divided by 2 into f1 minus f2. This becomes the time to get 0 displacement. Now again, as you start taking the time, so time, the first time is going to be 1 by 2 into f1 minus f2, correct? The next one is going to be 3 divided by 2 into f1 minus f2, or 5 divided by 2 into f1 minus f2, so on and so forth. Again here, if you take the difference between the two consecutive beats, okay, whatever it is, that difference is going to be 1 by f1 minus f2. It is true for maximum displacement and it is true for minimum displacement. In the sense that f1 minus f2, what you are seeing, right? That is what we call as the difference in the beat frequency. So this value, f1 minus f2, this is a very important value. This represents the number of beats per second. Okay, using this, we can calculate the difference in the beats between two different values. Alright, so now that you have understood how analytically we derive it, let's try to understand different applications of beats, from the next video onwards.